Hi, and welcome to day 5 of Intro to Trig. Today we are going to talk about reference angles on the unit circle. And what a reference angle is an angle which is positive and acute between the x-axis and terminal ray. Okay, so in quadrant 1, this is A, this is theta, this is B, which is our right angle, and this is C. We know that sine is positive because it's going up and down, and cosine is positive. Because this is on the unit circle, I'm just not drawing the circle. That means that AC is equal to 1. AB has to be positive because it's going in a positive direction, and BC has to be positive because it's going in a positive direction. And this is theta, my angle going from there to AC. In quadrant 2, draw my right angle. This is A, B, and C. Sine is still positive because it's going up and down. Cosine is now negative because x is going in a negative direction. So this is the positive acute angle, and this angle is actually theta. Okay, AC is equal to 1. AB is negative because it's going in a negative direction. And BC is positive. To find my reference angle, I'm going to take 180 and subtract from it theta, because there's 180 degrees in this straight line here. The x-axis is 180 degrees. And if I want to find this little teeny tiny angle inside my triangle, then I need to subtract it from 180. So if I have the sine of theta, it's going to be the sine of 180 minus theta. If we're talking about the cosine of theta, cosine is negative, because remember, all students take calculus, so it's a negative cosine of 180 minus theta. And tangent is also negative in quadrant 2, so it's a negative tan of 180 minus theta. In quadrant 3, my reference triangle would look like this. A is still here. This is still B on the x-axis. This is C. Here, cosine is negative, and sine is negative. AC is still in the unit circle, so AC is still on. AB would be negative, and BC would be negative. Our reference angle it starts on the x-axis. Here, that's theta. Which is just inside the triangle there. So in order to find that, I'm going to take theta and subtract from it 180 because my x-axis, again, is 180 degrees. And sorry, if I wanted to figure out what this little angle is, I have to take the whole value and subtract from it 180 to give me that little portion. So the sine of theta is going to be a negative sine of theta minus 180. And then cosine of theta is going to be a negative cosine of theta minus 180. And the tangent of theta is just going to be the tangent of theta minus 180 because in quadrant 3, only tangent is positive. In quadrant 4, my reference triangle looks like so. This is still A, this is still B, and this is C. AC is equal to 1, AB would be positive, and BC would be negative. Okay, sine is in a negative direction here, cosine is in a positive direction. My reference angle, in this case, again, the big sweeping angle is theta, and if I want to find the little angle inside, I'm going to have to go 360 degrees to figure out what theta is. So I'm going to do 360 and subtract from it theta to find my little reference angle. So sine theta is equal to negative sine of 360 minus theta. Cosine of theta is equal to positive cosine of 360 minus theta. And tan theta is equal to a negative tan of 360 minus theta. Okay, I know you're probably thinking, oh, I really don't need to know this stuff. This is just little. It's not going to make a difference if I learn this or not. But this is a huge, huge, huge topic that you really need to understand because this comes back and we use it a lot. Something I just want you to recognize is when I draw my reference triangles, they form a bow tie. When I put all 4 triangles together on one set of axes. So you know if you're drawing your triangles right if you can form a bow tie like that. They always start out from the origin and come back down to the x-axis. Everything is always in relationship to the x-axis. So what can we do with this stuff? Well, for the problems here, we have express each as a function of a positive acute angle, and B, find the value to 4 decimal places. Positive acute angle means use your reference angle or find your reference angle. So the cosine of 260 degrees. Well, 260 degrees is in quadrant 3. Okay, so it would look like that. And if I'm in quadrant 3, I'm going to do theta minus 180. Well, theta is 260. So 260 minus 180 is equal to 80. And since I'm in quadrant 3, cosine is negative. So it's a negative cosine of 80 degrees. And when we put this into the calculator, we put negative cosine of 80 degrees, we'll get negative 0.1736. The sine of 715 degrees, we need to find our reference angle. Well, if I go around once, that's 360 degrees. So 715 minus 360 is going to be 355. That's not quite all the way around again, but there's my reference triangle. So I need to find this little angle right up here. I'm in quadrant 4, so I do 360 minus 355, and I get 5. In quadrant 4, sign is negative, so it's a negative sine of 5 degrees. If I put that into the calculator, I will get a negative 0.0872. Tangent of a negative 110. Well, if I go negative 110 degrees, this is negative 90. That puts me into quadrant 3, but I need to know my positive direction. So that would be 360 minus 110, which gives me 250. So this is 250 degrees in the positive direction. I'm in quadrant 3, so I will do theta, which is 250 minus 180, which gives me 70. And in quadrant 3, tangent is positive, so it's equivalent to the tangent of 70 degrees. And when I put that into the calculator, I get 2.7475. Finally, I have the cosine of 168 degrees 20 minutes. Well, that puts me into quadrant 2. I draw my reference angle. This is the 168 20 minutes. So I need in quadrant 2 to say 180 minus 168 degrees 20 minutes. And I need something to subtract my minutes from. So I need to borrow 1 degree. 1 degree has 60 minutes. So it's 179 degrees 60 minutes minus 160, 68, not 86. 68 degrees 20 minutes. So when I subtract my minutes, 60 minus 20 is 40 minutes. 179 minus 168 is 11 degrees. So I'm in quadrant 2. That means cosine is negative. It's a negative cosine of 11 degrees 40 minutes. And when I put that into the calculator, I get negative 0.9793. Okay, reference angles are huge, so make sure you understand them. If you don't understand them, make sure you ask questions in class until you do understand them. Because these will not go away like some of the other things we do. We learn it once and we don't see it again until it's time for the exam. This will keep coming back over and over and over and over again. I cannot stress the importance of knowing how to do reference angles.